Okay, so a little bit of on the agenda that we're going to cover today. We'll be talking about what Google Cloud Platform is, kind of give you a quick overview of all the different products, make sure we're all on the same page as far as what the different components are and what they can do. We'll do a little bit of a deep dive into Compute Engine, and then Eric will take over and show you some really cool demos which illustrate how you can take advantage of Compute Engine using Puppet. Before I proceed, how many people here are already using any form of the Google Cloud Platform? Just a quick show of hands. And how many, so pretty small number, how many people have heard of it and kind of feel like they know what it is? So good, but it sounds like a lot of you don't, and that's great, because one of the things I wanted to accomplish today was to make sure you guys know about it and know what it can do for you. So this photograph is taken from a pretty cool site, google.com/datacenters, which has a lot of information about the Google data centers. This particular photograph is of one in Council Bluffs, Iowa, I think, 215,000 square foot data center. These are just massive, massive facilities. And these have evolved over 14 years to power all the different Google apps that you guys may be familiar with, from search to Gmail to Drive. And the kind of, in my mind at least, the central idea behind the Google Cloud Platform is to give you guys access to this amazing technology. So I'm going to walk through the different products that make up Compute Engine one by one, and we're not going to have enough time to really go into any one of them in particular, but I just want to give you guys a quick sense of what they are, what they can do. So starting with App Engine. App Engine is Google's platform as a service product. And so what that means is it gives you the ability to write your application relatively abstractly. We have 3 runtimes, Java, Python, and Go. And it gives you the ability to deploy your application in a way that you kind of send it into the net, and all the scaling is automatically kind of taken care of for you. So it alleviates that dilemma where you have to figure out how much hardware to provision, and you have to manage zones and regions and all that sort of thing. Very nice for the kind of situation where maybe you're a startup and you don't know how much traffic is coming, and you just want to have it automatically accommodate whatever load is coming your way. What I'm featuring here is something called the Cloud Playground. And at the end of the talk, I'll give you guys a link. You can actually come look at these slides yourself. It's an HTML5 website, basically, so you can click through a lot of the slides and try some of these things for yourselves. But anyway, this Cloud Playground is really fun. It's cloudplayground.appspot.com, and it gives you the ability to actually try it yourself and deploy applications on App Engine. So on the other end of the spectrum from platform as a service is infrastructure as a service. So you may be somebody who's really interested in having that fine-grained control over all of your computing resources. You want to create each computing element, and you want to manage the disks and everything else. And for that case, we have Compute Engine, which is, as I said, infrastructure. What I'm showing here is the web UI for administering Google Compute Engine, and I'll actually kind of quickly show you what that looks like. So this is a list of instances. You get a performance graph. There's not much happening on this particular performance graph because these instances are quiescent right now. But I can, for example, say new instance, and I can create a new instance. I can give it a description, tags. I can give it metadata. Metadata is abstract key value data pairs that are associated with either an instance or your entire project. You can kind of inherit them as well. It's a great way for propagating configuration information to your instances. And then I can specify lots of configuration details, like which zone I want to start the machine in, what machine type I want. This is a particular configuration of processor count, memory, disk arrangements, and so on. And I can specify some things about networking. I can also do some privileges and service account and permissions specifications here to manage like what I can do from these instances and so on. So I just click Create. And one thing I want to show you really quickly, because I understand there's a lot of developers in the room, we put a lot of effort into making this console very developer friendly. So you can click this button here called Rest. And this generates for you essentially what requests you would need in order to make a RESTful API request to perform the equivalent functionality of what you're doing with the web UI. So you can see you get post with some JSON document. And then in addition to that, you can also click on command line, and it shows you the GCUtil, that's our command line utility, command equivalent to do all this. And lest you be concerned about the length of this command, the auto-generated command is very expressive and verbose to try to cover all the options. But in a real-world scenario, if you were handcrafting your own, you could normally get away without going into all that depth. Lots of other things you can provision here: disks, images, networks. We have a new feature, built-in load balancing right into the fabric of Compute Engine. So don't have time to go through all those, but as you can see, a lot of the functionality can be done there. Cloud storage. So Google has a blob store, for those who are familiar with that term. It's basically a way to store unstructured binary objects in the cloud. And there are a lot of other vendors who have this kind of service. We're very proud of our performance and our consistency in this particular product. We have read after write consistency, which means you can upload a blob into this cloud storage facility. And as soon as you get the 200 OK from that upload, you can turn around and read that blob either from that same endpoint or from anywhere in the world, and you're guaranteed to see the bits you just wrote. So a lot of engineering work went into making that happen. We're very proud of it. We also have lots of nice additional features, like being able to serve content straight from web URLs, CNAME redirects for DNS, for using your own name to access your objects, and so on. But a very nice, complete, well-engineered cloud storage product there. Also administrable through the same cloud console we just looked at. We also have some nice storage capabilities. In addition to the one I just mentioned, we have a structured storage service called Cloud SQL. And what this really is MySQL database is hosted in the cloud. So again, there's a theme here, which is we're trying to take away the grunt work of managing resources and make it easier for you, so you don't have to worry as much about the details of administering these things, and you can just focus on what you guys do great, which is build applications. And then we have something called the Cloud Data Store. So the Cloud SQL is for structured data, very MySQL-like, very SQL query-oriented. The Cloud Data Store is unstructured data, so it's mostly NoSQL. I say mostly because it does have its own query language, but its primary use case is a NoSQL-style key-value storage. This isn't actually a new feature. This was something that's been used very heavily in App Engine. And what's new, or was new earlier this year, this was announced at Google I/O in May, is we're making this data store available to anyone, anywhere. So instead of just being available for App Engine apps, you can use it, for example, from Compute Engine. So it gives you a very nice built-in, almost unending, scalable NoSQL database from day one, managed for you. BigQuery is a very powerful query engine that we provide as well. This is built on Google technology called Dremel. And the idea behind this product is that most databases are really great when you do your queries on an indexed field. But if you happen to be doing interactive queries and you're not sure what kind of query you want to launch, you might find yourself wanting to query data that's not been indexed, and then you have to pay to index that field. The idea behind BigQuery is to embrace the table scan and not worry about creating indexes ahead of time. And using some very powerful technology, it makes it possible to have a schema-less but very efficient, queryable search engine. And so, not search engine, query engine, I should say. And so, if you haven't seen a demo of this, it makes possible some really amazing fast performance queries. For example, billions of rows can be queried with a query-like syntax in 3 to 5 seconds kind of response time. Very nice option for big data folks. And then, of course, there's lots of other APIs I won't go into here, and you have heard of them and probably using some of them. So, but I think the important message is that we have all these other APIs that we're working constantly on integrating and making them play well with our cloud, with the APIs and products I just talked about. So we feel like we have a unique combination of things, and the more we work on bringing them together and making them work well together for you guys, the more complete the package is for application developers. So that's the cloud platform. I'm going to switch gears a little bit now and talk about Compute Engine specifically. So Compute Engine is kind of a combination of virtual machines, networking, and storage that all works together to make it easy for you to build out your own infrastructure. One of the key points about it is that it's built with Google DNA. And by that I mean all of the knowledge and the experience and the engineering know-how, as well as the management, the operations aspects that we've been spending investing in keeping all these other Google products working really well and efficiently has kind of gone into the design of Compute Engine. And so we feel like we've built something that's really resilient, high performance, highly available, has all those characteristics that we've enjoyed for these other services. So instead of talking more, let me show you something so you can get a sense for how it works. So I have a demo here called Quick Start. And the idea here is we want to show you how quickly we can start a bunch of VMs. Whoops. So let's try to start 500 VMs now, and we'll see how long it takes. The way this app works is it creates a, just trying to shrink that down a little bit. It creates a matrix cell for every VM that it's just started, and it will essentially cycle through color coding to show you what state the VM's in. You'll initially see some blue, which means it's provisioning. Then once it's provisioning, we've just got a few of them coming up now. Once it's provisioned, it'll go yellow, which means it's staging. So we're loading the operating system and additional related software onto the virtual machine. And then eventually it'll go to the green color, which means it's actually up and running and available for you to use. So we'll let that percolate for a little bit. It's pretty quick, but I don't want you to have to sit there with me and watch it. So let me go back to my slides. Whoops. And I'm going to refresh this slide because it's a buildable slide, and I had it all built out beforehand. So I wanted to talk about the storage options that you have available to you when you're using Compute Engine. We've already talked about a few of them, but I wanted to fill in a little bit more of the picture. So you have Scratch Disk available. Scratch Disk is local to that virtual machine. So if you do something on a Scratch Disk on VM1, go to some other VM, you're not going to see it. It's localized. It's also ephemeral. So if you reboot, the data will still be there. But if you recreate the VM, that is, you destroy it and create another one with the same name, that data's gone. So it's not a great place to save important long-term data. The better choice for non-temporary files would be persistent disk. And this is really the recommended primary vehicle for data-intensive applications on Compute Engine. Persistent disk is localized in a zone, so it can be accessed by any VM in that zone. It's persistent, so anything you write stays written, whether that machine goes away or not. And it's very high performance and very low latency, and I'll show you an example of that shortly. We also have cloud storage, which I've already talked about. That's even higher level, whereas persistent disk is zone scoped. Cloud storage is global. Any VM anywhere can see that blob and use it. And I've already told you about Cloud SQL and Cloud Data Store. There's also this other option, because with Compute Engine you're getting a generic computing Linux box, essentially. You're free to run any database software you like, be it open source or commercial or private. So lots of use cases. Persistent disk, we really feel, is a big step forward. It was engineered to really add some advantages, and there are lots of important use cases like database storage, fast boot, so you can boot these devices right off of persistent disk. Static data distribution, by that I mean you can mount a persistent disk read-only by a number of VMs, and so you can use it as a way of communicating. And it's valuable for migration as well. There's a feature called snapshots, which lets you take an image of the contents of a persistent disk. And that snapshot can then be used to create additional persistent disks or to boot new virtual machines off of that image. So it gives you a lot of capabilities for backup and cloning of instances. So I've talked about consistency of data when I was talking about cloud storage, I was telling you how consistent it is. When you write it from point A, you can read it from point B. We're also very proud of consistency of our performance. So let's take a quick look at that. And by the way, coming back here, we see all 500 VMs started. That's great. Not 100% came up. And it started in a little under 3 minutes, which I think is pretty good. We've built a new demo into this app called DiskPerf. And what this is doing is it's sending a request to one designated VM in the group. It's number 0. And that VM is essentially taking that request and fanning it out to all the other VMs. And then eventually the other VMs, I say eventually because it doesn't seem to be doing anything, the other VMs will run an FIO command, which is a disk test, take the results back to the master, and then the master will feed it back to here. So let's try something. Let's try refreshing just in case that helps. Yes, I know which hotel I'm in. I just realized I need to. OK, so why this isn't working. The hotel is blocking WebSockets, or it's got a firewall or something like that. I ran into this before. So I need to be on my VPN. And it looks like it thinks it's on it. So I'm going to try to connect. So give me just a minute to see if I can get out of this or fix this. I will give this one shot. And of course, my phone is turned off.
That's why I use these little YubiKeys.
Yeah. Actually, have one in my hotel room.
You've got a screenshot, though.
Yeah. So let me go back to the screenshot. Thank you, Eric. Apologize for not showing you that. I was very excited about it. But here's what it looks like. You'll have to trust me on this. Here's what it looks like when it actually works. And after the talk is over, I'll figure out how to get it running. And if you're really interested in seeing this, come down to the stage. But anyway, it starts this disk test running on the first 50 VMs. And they run every 3 seconds, and they feed their results back. And what you see is the actual throughput across all 50 is amazingly consistent. And this graph is showing you that's the mean. The horizontal line is the mean throughput for the disk. And the actual requests are streaming style requests. So the use case is 1 megabyte reads sequential. So it's a good example of the performance you would see if you were streaming a video or some sort of media. OK. Quickly, we have some pretty advanced networking capabilities. We just introduced load balancing, which is a really nice capability built right into our network fabric. It's using the same load balancing features that we've been using to balance load in our other products. You get an internal DNS system built right into your network. So you can refer your applications and your command line tools and so on can refer to the VM names that you chose. And you don't have to worry about converting to IP addresses. Won't go into much more on that, but there's a lot of capabilities in the networking domain. A lot of time was spent on making that awesome. 2 more slides, and I will turn it over to Eric. One thing I wanted to share with you is the engineering team is constantly working on improving not only Compute Engine, but all of these products. Over the last 12 months, there have been 163 different features or performance improvements or significant upgrades to this product. We're really trying to move fast because this is a big space. There's a lot of important problems to solve, and we're dedicated to being successful in this product area. So keep an eye on it if you're interested in this, and you're going to see a lot of velocity. We're really proud of that. Last thing I want to show you is one of our customers used a Compute Engine cluster to do a large Hadoop. This was actually a Terasort. And so the heat map here is showing you, they all went green to show that all the nodes were ready. And then the color is showing you how hard they're working, not whether they're up or not like my other demo. But you can see in the left-hand side here, the map was going up to 100%. This video is going faster than I can talk. The reduce is now going up to being completed. And now we get a little zoom in on the result down here, or we'll click through to the result. So this is Hadoop doing a 1 terabyte, 1 terasort, sorting 1 terabyte in 55 seconds. And this broke the world terasort record, and it's using our standard computing equipment. There was nothing magic or special about this hardware. So we're very proud of the result they were able to obtain there, and I think it shows you what you can do with Compute Engine. OK, so with that, I will turn it over to Eric. I'm trying to figure out how to. There we go. I'll turn it over to Eric to tell you about how you can use Compute Engine with Puppet and make both products work better together.
Awesome. Thanks, Mark. That was a lot of information to take in. So a little bit more, I guess, in terms of, we'll focus more on GCE specifically, right? Because that's the thing that we can manage with Puppet right now. I think as I've been working on this project, one of the things, obviously, is that it just works, right? These are virtual machines running standard Debian and CentOS right now. More distributions will be coming, so stay tuned for that if you don't see your favorite distribution listed there. You can also build your own image. It's a little bit, you've got to jump through a couple hoops probably, but it's definitely supported. So the other thing I'll talk about is the variety of machine types. So as Mark talked a little bit about, it ranges all the way from small machines where you've got a single core, a little bit over a half a gig of RAM, all the way up to 8 cores and 30 gigs of RAM. And then you have those various options, storage options that Mark talked about with scratch disks or ephemeral disks versus persistent. The other thing that Mark touched on a little bit, and we'll talk about it a little bit more also, is the metadata and instance tags that you can use to help sort of catalog or organize your virtual machines, your GCE instances. So with that, I want to pop over to a demo. And you'll have to excuse my fumbling. Mark uses a Mac, and I use a Chromebook, and I don't know how to use Macs anymore. So, Mark, how do I find the other? Where's my other window?
I would try back there.
Down here someplace?
Yeah.
OK.
There you go.
So this is something you guys have probably all seen before. This is Puppet Enterprise, latest version I downloaded. And just talk a little bit briefly about this. This is Puppet Enterprise that's running on a GCE instance. And what I did is I selected the kind of the beefiest machine that we had. So that's the 8 cores, 30 gigs of RAM. So we were going to throw sort of 500 nodes at this. We wanted something that was a little bit bigger. So we went ahead and used that as an option. And we did a previous run of this, and when Mark runs the quick start demo and spins up those instances, 50 of those agents, or 50 of those nodes have Puppet Agent installed on them, and they will come along and register. I named this instance Puppet, so that's the default. So when a new agent comes up, it's going to first try and talk to Puppet, and that happens to be this Puppet master that I set up. So what I did is I've previously accepted the certificate requests on this, and so you see that I've got a list of those nodes there right now. I guess from that perspective, I'll tell you a little bit about how we set up the agents. So we wanted to demonstrate to you the fast startup boot times of creating 500 nodes. But what we did in order to also set up the demo so that it would work well with Puppet is for 50 of those nodes, we created a persistent disk ahead of time. The remaining 450 come up with the ephemeral disks. But they're all 500 came up brand new. The persistent disk, what we did to create that was we built an instance first, and we installed Puppet on that ahead of time. We got it kind of configured. We went through, I ran through the Puppet installer. I answered the standard questions to make it an agent or a client. We saved a snapshot of that, and then we built 50 persistent disks based off of that same snapshot. And then when Mark ran that quick start demo, it booted up those nodes. And as soon as they booted up, since they had a Puppet installed, they went ahead and registered themselves with the master. So flip back. So the other thing that we did to try and make Puppet take more advantage of GCE is we worked on a patch that we just submitted recently for Factor. Although there was, I'll mention this, you'll see down there highlighted where I've got virtual equals GCE. That support's been in there for a little while. So if you were running Puppet on GCE already, you were able to sort of detect that through the virtual fact. What we did is extend that a little bit more. GCE has a metadata service that we talked a little bit about metadata tags or metadata. There's a metadata service that you can hit from within the node, and you can use that to pull out more information about that GCE instance. So if it was booted, what machine type did it use? So you see I have a couple of them listed here. What project is it on? The machine type, the image, zone, lots of other variables that are coming in from the metadata. One thing that I thought was pretty neat as we worked on this was our metadata service allows you to basically fetch all of the data in a single HTTP request. So you can pass in some query parameters of like recursive equals true, and you can specify an output format, and you can get all of it back in one shot. So actually implementing this for Factor was pretty easy. Funny story, maybe not to everyone. I found out that JSON module doesn't work in Ruby 1.8.7, I guess. It is available in newer versions. And so when I built this, I did make that single HTTP request to the metadata service and asked it to come back in JSON response, loaded the Ruby module, everything was great until I went to go ask Puppet to merge that in and broke their build system. And that was earlier this week, I want to say. So I'd like to say special thank you to Jeff McCune and Josh Partlow for helping me get that sort of ironed out and fixed. So I say that it's coming soon. Factor will be, it's already merged, but the next version of Factor that comes out, I think there's a race between 1.8 and 2.0 is what I understood. But when that comes out, you'll have this available to you. So I'll just also, while I'm there, I'll show you the fact, I went ahead, when we built the Puppet agents ahead of time, we went ahead and put the Factor module on there, even though it's not technically available yet to you. So you can see here, what I did is went into the inventory search, and I put in GCE instance tag 0 equals staging. When Mark provisioned the instances, we went ahead and sort of randomly distributed the first instance tag to either be staging, production, dev, test, something like that. Just as a way to show you that you can use this as a filtering mechanism like you would with any of your other facts. And if we drill down into one of these guys, we should be able to see a lot of GCE facts, all prefaced with GCE. So interesting things, I mean, you can get to the SSH keys that are installed on there. These are the public keys for the accounts that are set up to use this instance. IP addresses, all of that stuff is available to you as facts. Let's see, I think I want to go back over here. So more awesome. There's another way that you can use GCE and Puppet, and that is through this GCE compute module, which is available on the Forge and has been for a while. This was originally written, I think, by Dan Bodie maybe a year and a half ago, I want to say. So what we did is we went ahead and grabbed that. We updated it for the latest version of our GCE API, v1 beta 15, I want to say. And we also added load balancer support into it. So you can actually use this, obviously, for with Puppet's DSL. You can take your site manifest files. You can update that to use actual native types for GCE. And you can use that to provision instances. You can build disks with this. You can set up firewall rules, load balancer configs. A lot of the basic stuff is available to you right there through Puppet's DSL. And I would like to walk you through a little example of that as well. So over here, I'm going to go ahead and just run this command. So for those of you, you're probably familiar with this. Puppet apply, I'm telling it a certain name. I'll show you what we did to set this up. And then I'm giving it a manifest file to run. And let me see, command shift minus.
Command minus.
Command minus. There you go. Hopefully everybody can still see that. Anybody in the back not able to read that? OK, good. So I got, cannot find, yeah. Helps if you're in the right directory. All right, so while that's chewing along, let's take a look at what that manifest file looks like. So when Mark shares the slides out to you, all of this code that we kind of hacked together to get a lot of this stuff to work is available to you to go take a look at as well. So in this manifest file, I wrote up instructions on sort of how I set this all up. It's all very standard stuff. I'm sure everybody that uses Puppet in here already knows all of this stuff. So I won't spend too much time on it. But down here, what I've set up is some variables that'll help you sort of group everything together. So I had everything start with the same name prefix. And you set what region you want this stuff. Load balancers are by region. Most other resources are by zone. So I specify those two parameters in there. And here you see I'm actually using the GCE types. So you have a GCE disk type, a firewall type, and an instance type. And you're passing in the parameters that are required for you to be able to create those instances. There's additional data that you can set, but this is sort of the bare minimum. So when you spin up a disk, you obviously need to tell how big of a disk do you want in gigabytes. Firewall, you can pass in what protocols and ports that you want to allow. And on a GCE instance, we'll just kind of walk through this really quickly. So I'm setting up 2 instances. This is dub1. And on the variables here, you'll notice one specifically. It's called manifest. And what this allows you to do, there's a couple ways that you can use this module now. One is you can go ahead and define an actual manifest that gets pushed out to the node. And it's, you're running this off of your master, presumably, and you're pushing this out to your agents. So you pass this manifest file out there. So this particular example, what I've done is I've said, let's go ahead and grab Apache. We'll customize the index.html file, and we'll go ahead and we'll boot up Apache once all of that's set up in place. And one thing I'd like to kind of call out here is we have this variable here called GCE external IP. So you have available to you within this templating system, you have the ability to be able to get to the external and internal IP addresses. And so you can use that once it gets deployed onto the node, that variable will be substituted by the value that is specific to that node. Those are the 2 variables that are supported right now. So we wrap it up with the include Apache to go ahead and get that triggered. The second instance is set up the exact same way. And then if we drill down in this a little bit further, you'll see that this is where we're setting up the load balancer config. And without kind of going into too much detail specifically about the load balancer, the 3 things that are required are setting up a health check, and that's that first one. And with the health check, you basically pass in a URL. By default, it'll use / to determine whether or not your instances are available. It just sends an HTTP request expecting to get 200. You'll set up a target pool, and that allows you to collect the instances that you want to be balanced or load balanced. And then you set up a forwarding rule. And so this is basically telling you the packets that go to this thing, where should they go. So in this case, we're saying anything that's going to go to this forwarding rule, you'll get a public IP back out of that. Will send traffic to port 80. So let's take a look. And hopefully we've got some progress over here on this side. So you can see here what we managed to do. It's just spitting out basically that it created these things. It created the disk, the 2 nodes, and set up the load balancing config. So I can use the gcutil command to get forwarding rule. And we named it bar dub 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 rule. And what this should allow us to do is get back the IP address that was used. So I can, let's see, 35.196.60. So that looks pretty much like what we told it to do over on the node. And just to show that we've got some load balancing there, let's do curl. Ooh.
No pressure.
No pressure. Okay, there. That's great. So we're bouncing back and forth between those 2 nodes, as you can see. Wow, that demo worked. So the other thing that you can do, obviously, is let's go ahead and tear this thing down. So I have another manifest, and we'll just walk really quickly through that. That's not going to be too surprising. So you can see here, it's basically the same variables that I had defined before, except that I'm ensuring that the resources are absent. And I'm using the DSL's chaining ability to go ahead and make sure that things are torn down in the proper order. There's multiple ways to do this. So it's basically saying I can't go and create a disk if I've got instances that are using it. So let's make sure that the instances are gone. Then I'll go ahead and get rid of the disk. Similarly with the firewall rules, you have to kind of break that down in a certain order also. Otherwise, the resources are considered in use. So that's what we've got here. And so that's what I just did. We don't have to do that again. And I think now is the time to pass it back over to Mark.
Thanks, Eric. I just wanted to leave you with a few closing notes here. We are really, as I've said a few times, really proud of the cloud platform that we've built. And we feel like it's bringing something really unique in terms of scalability, consistency, managing a lot of your resource needs, and incredible performance. Hopefully you also got a sense that Compute Engine and Puppet work really well together, and we hope to see more of that synergy, if I can use that word, in the future. And I really want to encourage all of you to give the cloud platform a try, whether it's Compute Engine and Puppet, like Eric's just been talking about, or any of the other aspects that I showed you today, or talked about at least. There's a link here where we're so confident that you're going to like this product, we're willing to give you $2,000 to try it. We think you're going to be very happy. So if you click through that link, there's a form. This is for Puppet users, where you can apply for the $2,000 credit for Google Cloud product platform usage. Also, these slides are available at bit.ly/gce-puppet. It should be available right now, as of now. If somebody out there is trying and can't reach it, let me know. As I said earlier, it's an HTML5 deck, so you should be able to go through the slides and see all the stuff we did today and click on some of the links and so on. You can learn more about our cloud platform at this link, cloud.google.com. Pretty easy. And lastly, I just wanted to thank you guys for coming and listening, being a great audience, and we'll take a few questions. Yeah, thank you guys very much.
Thank you.
I'm going to boot my phone so I can show that demo when it comes up. But yeah.
Quick question for you. Speaking of all the various types of disks, if you have the need for POSIX access to file systems on multiple systems, what do you recommend? I know that's the evil question in the world, but
the question was if you want POSIX access to a file system
shared across multiple systems.
Shared file system on one disk.
Or multiple systems, really. What do you recommend is the short answer.
So,
on multiple systems, though.
Right. So assuming you're talking about sharing data from one file system, I shouldn't have said one disk because there could be a distributed arrangement.
Yeah, one file system.
We don't yet have a native capability for doing, for example, read-write access to a persistent disk. You can mount a persistent disk from any number of virtual machines read-only. And when you do that, you can only read it. You can't write it at the same time from any of those devices, and you can't mount it read-write from another VM. So I don't have a good answer for you today. You can deploy
Glassdoor or Ceph, basically.
Yes.
I guess if I could jump in too.
Sure.
There is a S3 Fuse, supports Google Cloud Storage now as well.
Okay.
And I worked a lot with Tarek, upstream author of that, to try and improve the POSIX compliance of it. So there was a POSIX test suite out there, which definitely is old, but it basically runs through some of the standard POSIX sort of compliance tests, like Chown and Chmod and all of those kinds of things. So it does a pretty decent job at it. So your mileage will vary. It's obviously not going to be a high performance system, but if you're just looking for a way to distribute across multiple systems with read-write, I would encourage you to take a look at that. Yes, sir. Oh.
Actually, we were asked to have people who ask questions come up to the mic because it's being recorded, so if you wouldn't mind. And
hi there.
Well, you're already up there. You go ahead.
Okay. Can I build a FreeBSD image and boot that on the Google platform?
No. But we're very interested in supporting other kernels. And so stay tuned. We don't have anything we can talk about at this point, but we hear that we've heard a lot of interest in that feature, and we think that's an important capability.
Okay. Do you need direct support from the FreeBSD kernel developers, core group, that sort of thing?
When we get to that point, we would definitely reach out. Are you on the FreeBSD
I'm
team?
a ports committer, not a source committer, but I could certainly put you in touch with the right people.
Okay. Yeah, the links to our About Me profiles on the last page have our email addresses, and so you can reach out to us. Mine is Marc Cohen, MarcCohen @google.com. So feel free to share that with me if you would, so I can keep track. And also, if I can help anyone here with cloud platform questions, I'm happy to take email.
Great. Thank you.
Mm-hmm.
Just wondering, am I allowed to ask what hypervisor you guys are using?
Yes.
You can ask.
You're allowed to ask. I will actually answer. It's KVM.
Okay. And then second question is, do you have a plugin for Jenkins where I can spin up VMs and test code just like EC2 does?
It's on
is
the
more out here.
to-do list.
Okay.
Yeah, so it's a small team that's working on trying to get support for GCE into the open source products out there. And we obviously start with the big ones first, like Puppet and other ones. But we'll eventually get down a little bit lower in the list across different categories, and Jenkins is definitely on the list.
Okay. And one more question, if you don't mind. We do a lot of OpenStack where I am, but sometimes for load, we like to put stuff to cloud providers. Do you have the option of exporting VMs from OpenStack to this cloud?
Not now. It's an interesting idea, though. If you
Okay.
have some sense of how you would like that to work and what your use case would be, I'd be interested to hear more about it, but we don't currently support that.
Okay. Thank you.
I have a couple questions. Can Google Compute Engine can be used for the hyper compute clusters?
For the
SPC
High performance.
high performance,
HPC.
clusters.
yes. I mean, are you talking generically or a specific?
Yeah, generic SPC platform.
Yeah, I think it's quite suitable for high performance computing because not only do you pay as you go like most cloud providers, but with Compute Engine, we have a very nice pricing model where you only pay for the first 10 minutes of any hour you use per VM, and then you're charged per minute thereafter. So if you use 12 and a half minutes, you pay for 13 minutes. A lot of other providers, as soon as you incur a cost within an hour, you pay for that whole hour. So it's very economical, and because of our performance, we think we're very well suited to high performance computing.
The second question is the storage. You mentioned you have persistent storage. Besides that, you're looking at some other type of distributed storage system like Gluster and all that?
Yeah, can you use Gluster or some
Yeah,
other?
yeah, can you use-
I mean, you can build, and I mean, you're getting access to virtual machines that you have complete access to. So you get root access. You can install any software you want on those VMs.
I mean, the thing is that let's have a Gluster file system that is mounted across all the virtual machines.
Can you mount a file system
Yeah.
from? Yeah. So you control access within your cluster. You get this essentially a virtual network, and you get to configure all kinds of rules about what can access, what can get through to what other addresses using what protocols and so on. So you have complete flexibility. By default, when your network comes up, anything in your cluster can talk to anything else, but nothing from outside the network can come in with the exception of port 22, SSH can be connected, but it's quite an easy matter to open up HTTP or HTTPS or whatever other things you might want to allow in from the outside.
Thank
By
you.
the way, this is the, sorry, I cut you off. This is the demo I was wanting to show earlier. So you see the consistency of, these are 50 different virtual machines doing 1 megabyte sequential reads on 50 different persistent disks, and it's nice and consistent. Go ahead.
Okay. One question regarding the scalability. You mentioned that scalability is built into Google Compute Engine. So do I have to care by myself when CPU load is too high so that it automatically does something, or do I have possibilities of adding something like dynamic hosts, for example? I'm starting with 3 machines up to 10 depending on the load.
Right. So I hope I said that scalability, automatic scalability is built into App Engine. I didn't mean to say, if I did, that it's built into Compute Engine. We don't have a way to currently auto-scale your VMs. So you have a few options. We have some partners like RightScale and Scalar who do that very well, and you could use their products to auto-scale your Compute Engine instances. You also can run, there are a few open source options in that space as well that you're welcome to use.
Okay, thank you.
Mm-hmm.
I have a question regarding the Puppet usage. Do you guys actually use it for managing infrastructure, or just make available the integration for folks to use with Google Compute Engine?
I don't use it myself. I don't know if you are aware of usage inside Google or.
We do not use Puppet to manage your production network, no.
Any other questions? Yeah, one there. Can I trouble you to step up to the mic if you don't mind?
I was just going to ask why, or do you have any kind of automation?
Do we have any kind of what?
Automation?
You're talking about auto-scaling? Why don't we have auto-scaling, I think is your question, right? It's a really important capability that a lot of people need. That's all I'm going to say. It's a similar answer to the question earlier about why don't you have something important. We think it's really important to have it, and we don't yet have it, but working on it.
Hey, so I was playing around with Google Compute Engine about a month ago, and I noticed you have downtimes per zone for like a couple of days or at point weeks. The load balancing is only based on zone basis, right? So what do you do if your application is not distributed on an application level?
I think our load balancing has a regional orientation, so you can balance across multiple zones within a region.
Okay, thanks.
Sure. Looks like another one coming.
So my question has to do on the GCE. Do you allow just one external IP and one internal IP, or can you have multiple external IPs, multiple internal IPs?
Are you talking about for a cluster or for a single?
For a single host.
A single host. I think you can assign multiple. You can, first of all, by default, you get an ephemeral IP address, but you can request a static IP address as well. And that will stay fixed for that VM, so you can have predictability. I think you can have multiple static addresses assigned to a given VM, but I don't think I've actually tried that myself. Any other questions? If not, I'll thank you guys again for coming and wish you a good rest of the conference.
Thank you.